very good morning to all of you. Am I audible to everyone? Okay, so hopefully I am audible to everyone.
Yes, sir.
Okay, great, Mantu. Thank you. So, okay, just I'm sharing the screen now. So, anyone have you checked the syllabus of the first unit that anything is remaining in that syllabus? Anyone have you checked the syllabus? I think so. No. Am I right? Okay, so today is session number 4. Already we have completed first unit. The remaining portion, only last topics are remaining in the first unit, and the rest unit already have completed by Professor Power History. We have already completed. Now, the only last two topics that are remaining, that cogging and crawling and effect of unbalanced supply and machine performance, that we have already done. Clear? So in short, we have already completed first unit. Okay, now the second unit I'm starting, that is called single phase induction motor. If you have seen your syllabus, so already there the 5 units are there. Number 1, that is called induction machines. Number 2, single phase induction motor. Number 3, it's synchronous machine and motor. And last one, that is called special motors, special applications of motor, we can say, whatever you can call. Clear? So we have already done the first unit, we have completed. Second unit we have starting now. I'm starting now. Okay. So this is session number 4. Today I'm starting unit number 2, single phase induction motor. Subject name, that is EM2, you know very well, under the code of 310-3150910. Today I will discuss about constructional details of single phase induction motor and why single phase induction motor is not self-starting. So today we'll discuss about these two topics. First of all, what is the construction features of induction motor, of single phase induction motor, and why it is not self-starting. So today I'm going to discuss this thing. So first of all, a very good morning again to all of you, those who have joined. So a very good morning. Clear? And I know today's very less person have joined, only 6% have joined. I don't know why, because I think today's the exam also. So due to ADA, remedial exam of ADE, many persons they didn't join. But the persons who are belonging to MU, that is called international students, only I can see one name, I think so. That is Ismail. Only Ismail have joined from MU and none other the person. I don't know why. Ismail, can you tell me that why they are not joining the lectures? They have a sufficient knowledge like that? Ismail, can you listen me? Am I audible to you, Ismail? Because I have seen many, I have a keen observation to all of you that I am seeing that, I'm observing that the attendance is very, very poor. Maybe due to some remedy lectures that I can understand, that I understand, but sometimes it's not applicable. Clear? So Ismail, just I want to talk to you, if you can speak here, then else I will move further. Okay, I think so he's also busy. I think so he just attended, but he's not responding here. Okay, no problem. So the thing is that this time I'm going further, I'm starting my lecture, that the persons who are already joined, why should I waste time for that one? So the thing is that number 1, that is called constructional features of single phase induction motor, that it's a session learning outcome, means after today's session, what will you learn? So this is called session learning outcome, SLO. Clear? So after today's lecture, you will able to understand the constructional features of single phase induction motor, as well as you will be able to double revolving field theory, which will be applicable for the induction machines. And if time will allow, we will complete the third topic, that is called classification of single phase induction motor on the basis of different starting methods. Clear? So first of all, what is the single phase induction motor? What is the constructional features of induction motor, that I will discuss today. So that simple funda, बहुत simple funda that if you can understand, very simple is here. Single phase AC supply is commonly used for lighting purpose in shops, offices, houses, schools, etc. In your daily life, you can see at your surroundings, most of all, we are using all the equipment which are running only and only on AC. Clear? If you are talking about the like your grinder, mixer, refrigerator, whatever you are using, any moving part like grinder hai, washing machine hai. Clear? So grinder, washing machines, your trimmer also. So wherever you are using the motor, ultimately that motors are run by AC only. Clear? So of course we have a variety of motors, because that you know very well that if you are going to the classification of motors, electrical machine has the wide variety. Electrical machine has a wide variety, so that's why I'm saying many motors we have already surrounding us. Now the thing is that which motor is applicable for which purpose, that we have to understand. Clear? So that's why I'm saying, so we are having different motors around us. Now which motor is suitable for which application, that we have to understand. That's the main motto of your subject EM1 and EM2, so that you can understand what is the basic concept of each machine, what is the constructional features of each machine, and what is the working principle of each motors or generators or machine, we can say. Clear? So single phase AC supply is commonly used for lighting purpose in shop, offices, houses, schools, etc. Hence, instead of DC motors, the motors which work on single phase supply are popularly used. Why I'm saying these are popular? Because why these are popular? Most of all, we are using AC appliances, not DC appliances. That's why these motors are very popular. Okay. These AC motors are called single phase induction motors. A large number of domestic applications use single phase induction motors. Here we will learn how does single phase induction motor work. That's our lecture today. I will do. The power rating of these motors is very small. Very small means in terms of some 100 watt, 50 watt, or some fractional part. Some fractional part that is called means half HP. Okay, so the power rating of these motors is very small. Already I have said very small means in terms of some watts, not in kilowatt. Most of all, single phase induction motors are for 1 HP, half HP. And if you remember what is the meaning 1 HP, anyone can you tell me? How many watt in 1 horsepower? Anyone can you tell me? 1 HP equal to how many watt? It's a very common question. I think so everyone can answer. What I'm asking here, I'm telling to all of you first of all. I'm asking 1 HP, that is called horsepower, equal to how many watt, or you can say how many kilowatt, that I'm asking. Okay, so no one can give the answer. It's very difficult thing to understand that. Okay, so Gaurav have replied that 1 HP equal to 746 watt. Perfect. 746 watt, or we can say 745. That is also okay. Cute. Thank you. Or we can say 0.746. Sorry, 46, not 64. That is called 7. Just wait. 746. Clear? So 746 watt, or we can say 0.746 kilowatt. अगर आपको पता होगा, आप लोग जब अपने घर पे मोटर्स लगाते हैं जिससे हम लोग पानी चढ़ाते हैं ऊपर, the motors which we are using on the pumping system, suppose आपके ऊपर घर के ऊपर टंकी रखी हुई है, क्लियर, और on that tank you want to flow the water. So which motor are you using? I'm using 1 HP. हम लोग बोलते हैं ना 1 हॉर्स पावर की मोटर ले आओ, हाफ के ले आओ, ठीक है, 1.5 हॉर्स पावर के लिए 1.5 के ले आओ. So that means I'm using in terms of 746 watt, or that is called 373 watt, something like that, 375 watt. So these motors are very small, that I'm saying. So the power rating of single phase induction motor is always in nearly 1 HP, half HP, or 1.5 HP. Clear? So that I'm trying to say, first of all, you must know that power rating very small. Now I'm going further. Some of them are even fractional power. Fractional power means, already I said, 0.5, 0.25 HP, 0.5 HP, 0.02 HP, whatever you can say. Fractional का मतलब होता है 1 by 5 HP, 1 by 2 HP, 1 by 3 HP. So some of them are even fractional horsepower motors, which are used in application of very small toys, small fans, and hair dryer. Clear? These are very small motors. Now, similar to a DC motor, single phase induction motor also have two main parts that you know very well. Every machine have two main parts, that is called, one is called rotating and the other is called stationary. And that is very common sense to everyone understand that the stationary part is always called as a stator and the rotating part is called rotor. So if we are talking for any machine, every machine have two parts, that is called stator and rotor. Now in single phase induction motor, the stator has laminated construction. Clear? In single phase induction motor, the stator has laminated construction made up of stamping. Now what is the meaning of stamping here? Why we are using stamping? First of all, if I am saying the stator has laminated construction made of stamping, then first of all the question must be in mind that why we are using stamping and why we are using lamination for that. If we are not laminating, then what will happen? So the question must be in your mind. If it is not, then it must be there. So the answer of the questions like that, the stamping are lotted on its periphery to carry the winding called stator winding or main winding. So first of all, stamping that I am doing, or that I am lotting on the periphery to carry the winding. Which winding? That is called main winding or stator winding. And this winding is excited by a single phase AC supply. That's why this is called single phase induction motor, because we are providing as a supply of single phase. The laminated construction keeps iron losses to minimum. Already I have said why we are doing laminations, that must be in your mind. Because ऐसा नहीं कि जो भी पढ़ रहे हो that is okay, हाँ मैंने पढ़ लिया, that is sufficient. No, everything, whatever you are reading, whatever I am teaching, whatever you are reading, first of all it must be clear that why it happens. What is the use of this one? Why we are doing lamination? If lamination is not done, what will happen? So the thing is that if lamination is not done, of course your iron losses will be maximized. And if you are doing laminated construction, if you are using laminations on the stator, core, or we can slots, etc., whatever you are using the laminated construction, it keeps iron losses minimum. Clear? So we can say to minimize iron losses, we are always providing laminated construction. We are always using lamination. The stamping are made up of material from silicon steel, which minimize the hysteresis loss. So now everything have a meaning. Everything have a meaning here. Why we are using stamping? We are using stamping to minimize hysteresis losses. Why we are using laminated construction? We are using laminated construction for minimizes iron losses. Clear? The stator winding is bound for a certain definite number of poles. Means when excited by single phase AC supply, stator produces the magnetic field which creates the effect of on the certain definite number of poles. If we remember the machine, if you have seen, then already the main winding that always done on the stator winding is bound for a certain definite number of poles. Means excited by a single phase AC supply. The number of poles for which stator winding is bound decides the single speed of the motor, and the formula for that speed that is given by n is equal to 120 F by P. 120 F by P. This is called speed of rotational flux. Please keep in mind. This is called speed of rotational field. We can say the synchronous speed is denoted as ns, and it has a fixed relation with supply frequency F and number of poles P. The relation is given by n is equal to 120 F by P. The induction motor never rotates with the same speed, but rotates at a speed that is slightly less than the source speed. Means if I am saying induction motor will always run at the slightly less speed from the standard speed, we can say n is equal to 120 by P. The rotor construction is of a squirrel cage type. This rotor consists of uninsulated copper or aluminum bars placed in the slots. If there is any question in your mind, you can ask here. that bars, the bar means conductor, bar means conductor, the conductors, or we can say copper conductors, or we can say aluminum wires, bar, whatever you're using, that depends on your cost and your effectiveness. So the bars are permanently sorted at both the ends with the help of conducting ring, that is called end ring. The entire structure looks like cage, hence it is called squirrel cage rotor. The construction of single phase induction motors, just like, look, you can see this one. It's called cage type. This is called end ring. You can see this is called end ring. And that's why this is called squirrel cage. That means that it looks like cage. Cage means pijra. Clear? And this is your symbolic representation of induction motor. This is your slots where I'm putting the winding conductors. As the bars are permanently sorted to each other, the resistance of the entire rotor is very, very small. The air gap between stator and rotor is kept uniform and as small as possible. Keep in mind, air gap, what is the air gap? First of all, if you know, that is called rotor. This is stator. Clear? So this is the part of something air gap, this one, this line we can say. This is stator, this is rotor. So in between that, some air gap will be there. But the air gap must be very, very small. Please keep in mind. Clear? Air gap must be very, very small. The main feature of this rotor is that it automatically adjusts itself for the same number of poles as that of the stator winding. That's the main feature of this cage rotor. So you can see this time single phase supply. This is your number of poles, single phase. This is single phase stator winding. Clear? And I'm giving supply to stator winding. At that time, this squirrel cage rotor is there. Clear? In this cage, you can see these conductors are there. Clear? Now, and this is shaft is there. Now what's happening? If you are providing some supplies here, clear? So what will happen? This supply will produce some MMF, that is magnetic field, and that magnetic field will produce some flux, and that flux will be linking with this conductor inside the rotor. And whenever any flux is linking with the, whenever any conductor is linking with the flux, or we can say flux linkage is there, then what will happen? Some EMF will be there. Induced EMF will be there. Clear? Or some force will be there. So that's I'm saying, that's the principle. For the motoring action, listen, not I'm saying generating action. For the motoring action, there must exist two flux which interact with each other to produce the torque. In DC motor, field winding produce the main flux, while DC supply given to the armature is responsible to produce armature flux. मैं बात कर रहा हूँ DC motor की. DC motor में क्या होता है? In DC motors, I am providing field winding produces the main flux, while DC supply given to the armature. Clear? While the main flux and armature flux interact to produce the torque. Now, in single phase induction motor, what's happening? Single phase supply is given to the stator winding. Keep in mind. In DC motor, we are providing field winding produces the main flux, while DC supply given to the armature is responsible to produce some armature flux. दोनों फ्लक्स अभी क्या करते हैं? इंटेक्ट करते हैं and they produce some torque and machine is running or motor is running. While in single phase induction motor, single phase supply is given to the stator winding. The stator winding carries an alternating current because of course if we are providing AC supply, अगर हम supply AC देंगे तो current भी कैसा होगा? Alternating होगा. Now the stator winding carries an alternating current. What is the meaning of alternating? Means which is changing at every aspect. So the stator winding carries an alternating current which produces the flux, which is also alternating in nature. Supply is AC, current is alternating, and that's why the flux is also alternating in nature. This flux is called the main flux. Now this is the working principle of induction motor. Please keep in mind. Now this flux links with the rotor conductors, and due to the transformer action, EMF gets induced in the rotor. Now the induced EMF drive current through the rotor. Are you getting my point? What I'm doing here? First of all, I'm providing AC supply to the stator winding. Clear? Now stator winding producing some alternating flux in nature, and that flux is linking with the rotor conductors. And due to transformer action, EMF is generated because E equal to minus N d phi by dt. E equal to minus N d phi by dt. Clear? So if your flux is alternating in nature, clear, some number of turns in the rotor winding, number of conductors are there. So what happened? Some EMF will be there, and what the produce what the effect of this EMF? This EMF will run or will produce some current in the rotor conductors. सप्लाई हमने दिया स्टेटर वाइंडिंग पे, वहां से सप्लाई दिया, स्टेटर वाइंडिंग सप्लाई दिया, तो उसमें कुछ वाइंडिंग कुछ करंट गया, तो करंट क्या करेगा, कुछ फ्लक्स अल्टरनेटिव कुछ फ्लक्स जनरेट करेगा, एंड वो फ्लक्स क्या करेगा, दैट फ्लक्स इज लिंकिंग विद द रोटर कंडक्टर्स। और रोटर कंडक्टर क्या करेंगे, जैसे ही फ्लक्स आपका जैसे ही फ्लक्स लिंक होगा, एट दैट टाइम इन रोटर सम ईएमएफ विल बी देयर एंड द रिजल्ट ऑफ दैट ईएमएफ विल बी करंट। क्लियर? द रिजल्ट ऑफ ईएमएफ विल बी करंट and that current is flowing in the rotor circuit. Now this rotor current produces another flux. Clear? अपने पास rotor current है, समझना मेरी बात को, rotor current means that is called IR we can say. अपने पास rotor current आ गया and number of conductor भी हैं, तो N भी आ गया, so again NI will produce some rotor flux that is called phi R. एक phi M था, main flux था, वो किसमें दिया था, स्टेटर वाइंडिंग में। Are getting my point all of you? को समझ में आ रहा भाई? All of you are getting my points? What I'm trying to speak here? Okay. If there is any doubt, Gaurav, Rohit, anyone, कहीं भी कोई डाउट लगे प्लीज यार बोल देना, ठीक है ना? So what I'm doing here? First of all हमने स्टेटर वाइंडिंग सप्लाई दिया, क्लियर? मैंने क्या किया, फर्स्ट ऑफ ऑल आई हैव प्रोवाइड सप्लाई ऑन द स्टेटर वाइंडिंग, स्टेटर वाइंडिंग सप्लाई दिया, तो स्टेटर की वाइंडिंग कुछ करंट फ्लो हुआ, सो दैट्स बाय सम फ्लक्स क्रिएट हुआ वहां पे, एंड वो फ्लक्स कहां से लिंक किया, रोटर वाइंडिंग में लिंक किया। रोटर वाइंडिंग में भी कंडक्टर्स हैं, तो ड्यू टू फ्लक्स लिंकेज ऑफ रोटर वाइंडिंग कंडक्टर एंड फ्लक्स इन द स्टेटर, सम ईएमएफ विल बी प्रोड्यूस इन द रोटर वाइंडिंग और रोटर कंडक्टर्स। अब रोटर का क्या हो चुका है अपने पास, रोटर के अंदर करंट आ चुका है, सो दैट इज कॉल्ड रोटर करंट। So due to this rotor current and due to number of conductors in the rotor, some flux will be creating in the rotor position also. That is called rotor flux. अब अपने पास दो फ्लक्स हो चुके हैं, एक मेन फ्लक्स था जो स्टेटर में था, दूसरा फ्लक्स आ चुका रोटर में, क्लियर? So now what's going on? The second flux, what is second flux? Rotor flux is produced according to the induction principle due to induced EMF, hence the motor is called induction motor. हर चीज का एक पॉइंट होता है, why it is called induction motor? Because the second flux which it produces in the rotor due to rotor current and number of conductors in the rotor winding, some second flux is produced, and that second flux, that is called rotor flux, is produced by only induction principle. That is called equal to minus n d phi by dt. That's why this is called induction motor. As against this in DC motor, a separate supply is required to the armature to produce armature flux. This is an important difference between DC motor and induction motor. Please keep in mind. This is very, we can say very important point or difference between DC motor and AC motor, because as against this in DC motor, a separate supply required to the armature to produce armature flux. But what I'm doing here, I'm providing only one supply to the stator winding, clear? And due to stator winding, due to a stator flux, some EMF will produce in the rotor winding, and that EMF will flow some current in the rotor winding. That's why there is some another flux is there. So there are two fluxes are there. Now the key point, or we can say the main point, another important difference between the two, which two, DC motor and AC motor, or we can say induction motor, between the two is that the DC motors are self-starting. Please keep in mind. While single-phase induction motors are not self-starting. This is very, very important point. Now let us see. We can say, let us discuss that why single phase induction motors are not self-starting. Why it's happening? Why they are not self-starting? With the help of a theory called double revolving field theory. Clear? So now I am going. First of all, I have discussed the working principle. I have discussed the construction principle, construction features of induction motor. Now I will discuss about one topic, that why single phase induction motors are not self-starting, and that theory you can understand with the help of theory that is called double revolving field theory. So now, first of all, what is the double revolving field theory? Just wait. Okay. Okay. So now we are discussing that what is the meaning of, what is the importance of double evolving field theory. Anyone, अच्छा जितना अभी तक पढ़ा है, anyone can you say कि what we have summarized? Anyone can you summarize कि हमने अभी तक क्या discuss किया? What we have discussed till now? Anyone can you summarize? Else I have to call a name. Till now, what we have discussed till now. Summarize that thing first of all. Okay, I have to call a name first of all. Bhavesh, are you listening me? Mr. Bhavesh? Now to take attendance by calling a name first of all. Kyur, are you here? Kyur Joshi? Kyur Joshi, are you here? Okay, Bhavesh? No. Okay, Gaurav Kumar?
Yes, sir.
Okay, so at least you are attending the lecture. बाकी सब तो कोई lecture बस attend कर रहे हैं. So just wait, just minute, just मैं आपको पूछता हूँ. I have to call a next name also. Rohit Bayam.
Yes, sir.
Okay, done. Vijay, D2D 501. Vijay,
Yes, sir.
great. Well, at least you are walking, waking up. जग तो रहे उतना काफी है. Okay, Aman Ali, Aman. अमन भाई.
Yes, sir.
Okay, done. Just checking कि आप लोग सो तो नहीं रहे हो. Just I'm checking first of all, then I will continue my topic. Arwaj.
Yes, sir.
Okay, समीर भाई. समीर. Okay, so लगभग 2 से 3 लोग सो रहे हैं, ज्यादा नहीं सो रहे. Now, okay, just I will ask to Rohit. Can you tell me, Rohit, मैंने अभी तक क्या डिस्कस किया? What we discussed till now?
सर कि ये सबसे पहले हम डिस्कस किया कि एसी सप्लाई किस किस चीज में से यूज होता है. कॉमनली यूज होता है ऐसे लाइटिंग पर्पस के लिए. फिर हमने डिस्कस किया एसी मोटर सिंगल फेस इंडक्शन मोटर बोलते हैं और उसका पावर रेटिंग बहुत स्मॉल होता है. और ज़्यादातर ये मोटर यूज होता है स्मॉल टॉयज और ये स्मॉल फैन इस. और फिर उसके बाद हमने लेमिनेशन के बारे में थोड़ा एक लाइन किया कि लेमिनेशन आयरन लॉस को कम करने के लिए यूज होता है. फिर मोटर के 2 पार्ट्स होते हैं. मोटर के 2 पार्ट्स होते हैं, एक स्टेटर और रोटर. और फिर उसके बाद हमने थोड़ा सिंक्रोनस स्पीड के बारे में किया कि उसका फॉर्मूला NS = 120 F/P होता है. फिर इंडक्शन मोटर never rotate with the synchronous speed, but its rotate speed is slightly less than a synchronous motor है. और फिर हमने स्क्विरल केज के बारे में क्या कि इसका कंस्ट्रक्शन क्या होता है. और इस कंस्ट्रक्शन में कॉपर और एल्यूमिनियम बार कॉमनली यूज होते हैं. फिर हमने उसका डायग्राम देखा सिंगल फेस मोटर का. इसमें सिर्फ सिंगल वायर होता है और एक रोटर होता है बीच में. फिर हमने इसका कंस्ट्रक्शन देखा. फिर उसका प्रिंसिपल देखा कि स्टेटर हम पहले सप्लाई एसी सप्लाई हम स्टेटर वाइंडिंग को देते हैं. स्टेटर वाइंडिंग अल्टरनेटिव करंट कैरी करता है जो अल्टरनेटिव नेचर का फ्लक्स प्रोड्यूस करता है स्टेटर में. वो होता है हमारा मेन फ्लक्स. और वो मेन फ्लक्स लिंक होता है रोटर से और वहाँ पर ईएमएफ प्रोड्यूस होता है. उसके ईएमएफ और वो ईएमएफ हमारा करंट प्रोड्यूस करता है रोटर में. फिर फिर
Continue,
रोटर के
continue,
अंदर
continue.
अच्छा, रोटर के अंदर हमारा करंट तो पहले से प्रोड्यूस होने लगता है, और हमारे पास पहले से कंडक्टर्स होते हैं, मतलब Ni हमारे पास है, तो वहां पर एक और हमारा एक और फ्लक्स प्रोड्यूस होता है हमारे, और वो होता है हमारा सेकंड फ्लक्स। और क्या
Great. बहुत बढ़िया. Good, Rohit.
हाँ, हमारा उसको बोलते हैं रोटर फ्लक्स।
That is called second flux, or we can say rotor flux. Perfect.
रोटर फ्लक्स, तो ये सेकंड फ्लक्स के इसके इसीलिए इसको हम इंडक्शन मोटर बोलते हैं,
बराबर, because already
क्योंकि
we are producing like second flux with the help of induction principle. Good.
इंडक्शन प्रिंसिपल
Done. Perfect. Perfect. Good.
called this motor induction motor.
Perfect.
फिर then we bus then the
Then
there are key
okay,
point.
Rohit, just I'm continue now. No problem. Thanks. Seriously, that's you have described everything very clear way, and even you can say, we can say, I can say just you didn't left anything from the first, just from the first minute of the lecture, from 9-1, whatever I have said, you have defined very well clear, and the same thing expecting from all of you. Please, it's a request to everyone. Now, Gaurav Kumar.
Yes, sir.
Gaurav, have you checked the first unit that is called induction machine? That is already, I think, syllabus have been completed or not. I'm not sure because already I have taught only last 2 topics. So have you checked it out that the whole unit first is completed or not? The all syllabus is completed. All content of the first unit have completed. Have you checked for that one?
I think last topic was crawling and cogging. It's
Dear, Gaurav, already have completed 2 last topics, that is called crawling and cogging, and effect of harmonics and effect of unbalanced supply voltage on machine performance. So these last topic that I've covered, but I am asking the previous topics. So all topics have been covered or not, that you have to check. So that's I am asking to you. They have already completed or not? These topics have been completed.
It's completed, sir.
So have you checked the syllabus throughout?
Yes.
Okay, done. And why I'm saying so, because already we have shifted today on the second unit that I'm teaching today, the second unit that is called single induction motor. But because I don't know what already the Pavak sir have already given the syllabus that we have covered this topic. But instead of the topics, if there is anything remaining, you can discuss to me. I will teach through that topic, no problem. Clear? So again, I'm saying once again. So just I'm saying again, once again, you can check your topics that which is covered, which is not covered. If there is any left, there is any topic left, then don't worry, I will shift to you. Okay, so already I have started second unit, so I'm continuing now, and thanks to all of you for this awareness that already you are joining the lecture very well and you are answering. So that's thanks to all of you, those who are joining here. So now we are talking about the first of all principle of the induction motor, that how it's running. So already I said single induction motor, single phase induction motor is not self-starting. So what is the meaning of double phase revolving theory? First of all, that we will discuss this one. Now in double phase revolving theory, according to this theory, any alternating quantity can be resolved into 2 rotating components. Any alternating quantity means if I'm saying voltage, current, any alternating quantity can be resolved into 2 rotating components which rotate in opposite direction and each having magnitude as half of the maximum magnitude. For example, suppose I'm saying this is the E voltage. Now, if I'm writing the equation E equal to Em sin omega t, so of course this is alternating, there is no doubt. If I'm writing E equal to Em sin omega t, so we can divide this E component, which is alternating in nature, in 2 parts, that is called Em1 by 2, Em1 by 2, or another part that is called Em1 by 2. Clear? The thing is that you can see already I've said we are having magnitude as half of the maximum magnitude. Matlab, if this is Em or Em1, I'm using half in the one component, half in another component. Clear? So what they are trying to speak here, they are saying that just according to this theory, any alternating quantity can be resolved into 2 rotating components. Rotating means it must be rotating in clockwise direction or anti-clockwise direction, which rotates in opposite direction always. Suppose I'm saying this is your Em, for example. Suppose I'm saying this is Em. So we can say half Em by 2 will be here, and half Em by 2 will be here. This is called double This is called double field leveling theory. This is called, and this is your EM. So again, I'm saying any alternating quantity. First of all, keep in mind, no DC quantity. Don't say like that 50 volt hai, to 25 20 volt either rotate karega. No. Already I said, according to this theory, any alternating quantity, that is called, what is the meaning of alternating? That is called EM sin omega t, EM cos omega t. So that you know what is the meaning of alternative. You know very well. So any alternating quantity can be resolved into two rotating components which rotate in opposite directions and each having magnitude as half of the maximum magnitude of any quantity. In case of single induction motor, the stator winding produces an alternating magnetic flux having the maximum magnitude of phi 1 m. Already I have said that whenever we are providing any single phase AC supply to the stator winding, some alternating current will flow in the stator winding, and due to that current and due to some number of conductors in the stator winding, some MM will be there, and that MMF will produce some stator flux that is called main flux. So what I'm calling that main flux, that is called phi 1m. Phi 1 means stator, phi 2 means rotor. Again I'm speaking. Phi 1 I am saying here stator, phi 2 I am saying here rotor, but phi 1m means maximum value of that alternating flux in the stator. Phi 1m means maximum value of stator flux. Now we can divide this flux in two parts. So according to double revolving field theory, consider the two components of the stator flux, each having magnitude half of the maximum magnitude, that is called phi 1m divided by 2. Both these components are rotating in opposite direction. If you are phi 1m by 2, that is called, मैं इसको नाम दे देता हूँ, just I'm saying this component I'm dividing two parts, that is called, one is called phi 1m by 2, इसको बोलते हैं phi f, forwarding flux, and second component phi 1m by 2 we can call it the reverse flux, phi r. So you can use two flux, that is called forward or reverse. Clear that you can use the word for the giving anti-clockwise direction to each other. Clear. So both these components are rotating in opposite direction as the speed ns, which is dependent on frequency and stator force. That already I have said the formula, ns equal to 1/120 f by p. Now let phi f, already I said what is the phi f, forward component of rotating flux in anti-clockwise direction, while phi b is the backward component rotating clockwise direction. Clear. The resultant of these two components at any instant gives the instantaneous value of the stator flux at the instant. Means whenever we are giving a vector summation of phi f and phi b, we are getting the total phi m, that is called main flux, or we can say stator flux. So resultant of these two is the origin stator flux. But keep in mind, resultant means I am saying vector addition. If you are reading here induction motor, that is called AC motor, and everything is alternating in nature, so please keep in mind wherever the summation will be there, summation will be only vector sum. कभी भी कोई alternating quantity की बात करते हैं, उसके summation की बात करें, तो please keep in mind we are talking about vector sum. Never do arithmetic sum for any alternating quantity directly. Now the blue figure, you can see the figure. Suppose this is already as said, if this is phi 1m by 2, so we have divided phi f, phi b. Already why I am saying, because already I have said phi 1m is the maximum flux and we have divided in two parts. So you can see this is your anti-clockwise and this is your clockwise. So ultimately this is your waveform. So we are dividing these two components into half of each other. At the start, both the components are shown in the opposite direction to each other in figure 1 that I will just present. Thus the resultant flux phi r is 0 at the starting. I am saying this is nothing but the instantaneous value of stator flux at the start. Clear. And that's why the resultant flux is 0 at the starting, and that's why the machine is not self-starting. After 90 degrees, as shown in figure B, the two components are rotated in such a way that both are pointing in the same direction. Hence, the resultant phi r is the algebraic sum of both magnitude, that is called phi 1m by 2 plus phi 1m by 2 equal to phi 1. Clear. I am saying I have already written algebraic sum of only magnitude. Clear. Keep in mind. So this is nothing but the instantaneous value of the stator flux at 0 equal to 90 degrees as shown in figure C. Already I have also the figure C, that is called figure C, if you can see it. Here 1 2 3, this is figure A, figure B and figure C. Now what's happening? If I'm saying about the 0 degree, at 0 degree, what is the stator flux? What is the starting flux? That is called 0. Why? Because phi f equal to minus phi b. So if I'm finding the resultant flux at figure A condition, what will happen? The resultant flux at starting will be 0. Why? Because both are the equal each other and opposite each other. So what is the answer? So this will be cut to each other and the resultant flux will be 0. While at 90 degree, what will happen? At 90 degree, it will be here. If this is rotating like that, it will be here. This will be here. So at 90 degree, we are getting maximum flux. Clear? So again, same for 0 degree, for 90 degree. Again, when talking about the 180 degree, so what happen? Again, the resultant flux is 0. Again, 270 maximum flux in opposite direction, and again 360 0 flux. Clear? So in double field revolving theory, what's happening at every 0 degree or 180 degree, the resultant flux will be 0. Clear? So that's already I have said. That's why the machine at starting, because what is at starting means 0 degree. At starting, the resultant flux is 0. So that's why the machine will not rotate. Clear? So both the components are rotating and hence get cut by the rotor conductors. Due to the cutting of flux, EMF gets induced in the rotor, which is circulating a current. The rotor current produces rotor flux. This flux interacts with the forwarding component phi f to produce a torque in one particular direction, say anti-clockwise direction. Clear? What I'm doing here already I have said, because phi f and phi b, these are the two components of phi m. Clear? Now, due to these components, at every 90 degree to 70 degree, some flux is generating and some flux is linking with the rotor conductors. And again, whenever the flux is linking with the rotor conductors, some EMF will be there. And due to the rotor current and number of conductors in the rotor winding, again some flux will be there. That already we have discussed in the last slides. And that flux will interact with the forwarding component phi f to produce a torque in one particular direction, say anti-clockwise direction. While the rotor flux interacts with the backward component phi b to produce a torque in the clockwise direction, because there are two components. So if anti-clockwise torque is positive, then clockwise torque is negative, of course. Clear? So what's happening at the start? These two torques are equal in magnitude but opposite in direction. So that's why each torque tries to rotate the rotor in its own direction. Thus, net torque experienced by the rotor is 0 at the start. Hence, the single phase induction motor are not self-starting. So hopefully, have you got the point? What is the double field revolving theory? Is there any doubt? We have discussed there are three flux are there. First, it's called first, that is phi f. Second, phi r. Both are the component of main flux, that is called stator flux, and both flux phi f and phi r is also linking with the phi 2, that is called rotor flux. Clear? And whenever they are linking with the rotor flux phi f and phi 2, phi r and phi 2, so of course we are giving reverse direction of torque. Clear? And at the 0 degree, that is already I've said, at the starting 0 degree, phi f and phi r both are equal. So that's why both are creating same torque in opposite direction. So what is the net torque on rotor? It will be 0 at the starting, and that's why single phase induction motor are not self-starting. So is there any doubt in this topic? Because this double field revolving theory is very, very important topic for all of you. That's why. To understand the basic concept of, or we can say basic running principle of single phase induction motor. So is there any doubt to understand double field revolving theory? Okay. Gaurav, any doubt is here in this theory? Okay, done. Good, thank you. So now I'm going further. Clear? So already हमने ये discuss कर लिया था. What we have discussed till now? What is the induction motor? What is the single phase induction motor? How is it differ from DC motor? What is the construction principles? What is the construction features? What is the working principle? Why it is not self-starting? What is the main double field revolving theory? So till now we have discussed this thing. But the thing is that if motor is not self-starting, then how it works? So that is called classification of single phase induction motor. Because already I said induction motor is not self-starting. But if it is not self-starting, so what we have to do? We have to provide some additional torque at starting position only. Why I am saying so? Because at 0 degree, only at 0 degree, the net torque is 0. While at 90 degree, the net torque will not be 0. So what we have to do at starting, at the 0 degree, or we can say at the starting, we have to provide some additional force, additional torque to run the motor. And for which I'm providing some additional flux, or we can say we are providing some additional torque. There are some methods to start the motor. And on the basis of that methods, or we can say on the basis of that additional flux providing methods, we are defining some types of single phase induction motor. So already we have written the slide, you can read. Single phase induction motors are made self-starting by providing additional flux by some supplementary means, that is called additional, some methods are I'm using there. So single phase induction motors are classified depending on how this additional flux is generated. So number one, that is called split phase induction motor. Number two, that is called capacitor start induction motor. Number three, that is called capacitor start capacitor run induction motor, CSCR induction motor. Fourth, that is called permanent split capacitor, that is called PSC motor. And fifth one, steady pole induction motor. Clear? So this is the topic we have covered till now, that is called classification of induction motor. Okay. So again, I'm summarizing the topic. First of all, that we have first of all we started that what is the meaning of single induction motor. Clear? What is the power rating of these types of motor? Already I've said these types of motor have very small rating in terms of some fractional HP, that is called 1 HP, 1.5 HP, or half HP, or 1 by 4 HP, 1 by 8 HP. So already I've said that these motors are very small. In most of applications, in most of all home appliances, we are using out of now single induction motor. In terms of your small toys, small robots, dryers, washing machine, etc., we are using at your grinder also. So we are using most of all. Clear? So we have discussed this thing. First of all, what is the power rating and how it looks the motor. Then we have discussed about constructional features. Means what is the structure of rotor, what is the structure of stator, which type of winding we are placing in the stator, what is the meaning of laminated structure, why we are doing lamination, okay, why we are doing stamping. So already we have discussed that lamination, or we can say laminated structure we are doing to avoid iron losses, or to minimize, not avoid, we can say to minimize iron losses. On the other hand, the stamping we are using to minimize or to avoid hysteresis losses. Then we have discussed about the construction of a stator and rotor, that we have discussed what is the meaning of spherical rotor and why it is called squirrel cage rotor, because it looks like a cage. That's clear. What is the meaning of end ring, why we are sorting the end, why we are sorting all the conductors by the end ring, what is the advantage of that. So already I have said, because for doing just doing like that, the rotor resistance will be very, very small. Clear? So of course the current will be high, and at that time, the same time, current will be high due to number of conductors in the rotor, your flux will be high, and that can provide sufficient torque. Clear? Or we can provide at high torque, whatever the required the after self-starting methods. Clear? Next we have discussed about that why induction machines are not self-starting. What is the meaning of double feed revolving theory? This we have discussed. And on the basis of the theory, double feed revolving theory, and the basis of the discussion of not starting single phase induction motor, we have discussed that classification. What is the meaning classification means? Single phase induction motors, if they are not self-starting, so of course we have to start. So we have to provide some additional flux, we have to provide some additional accessories, or we can supplementary means to start. So that's why on that basis we have discussed some types of induction motor that already you can see the screen, last slide of your lecture. Split phase induction motor, capacitor start induction motor, CSCR induction motor, PSC motors, and set pole induction motor. In next lecture, we'll discuss about all constructional features and working principle of all types of motor. That is in our syllabus. Clear? Also, we'll discuss about the torque, speed characteristic of induction motor, how it looks, and what is the meaning of motoring action or generating action, and what is the other actions of what is a stable region or non-stable region. Clear? So if there is any question or any doubt from your side, we can discuss now. Any question from anyone? We have summarized very well. If you have any doubt, you can speak already. So I think so there is no question. Gaurav, all things is clear? Or anything? Okay. Arvaj, any question? Samir?
No, sir.
समीर तो लगता है बस अटेंड करके सो गया नहीं Okay, so no questions. Thanks to all of you. You can write a roll number in the chat box, and then we'll end the session.
सर मैं भी नाश्ता करने गया होगा.
Okay. Just write a roll number in the chat box. We'll end the session now. And after writing a roll number, you can leave the session. Thanks to all of you. First of all, I will request to everyone, please write a roll number in the chat box. I will take attendance from the chat box. Okay. And if you read in the number, then you can leave so that I can end the meeting on time. Okay, so just I'm ending the session now. Thanks to all of you.